Yeah, hi guys. Today we are going to discuss about the high availability. Okay, high availability is an important topic in any network. Okay, this is mainly used for the redundancy. Okay, redundancy means to avoid the single point of failures. If you have any single device in your network which is managing, if that single device fails, your entire network will go down, right? So in that case, what we can do is we can deploy another firewall or another device. In this case, we are talking about the firewalls, right? We will be having two firewalls. One will be acting as an active, and other will be acting as an passive. Okay, and all the real traffic will be flown using an active firewall. Whenever the active firewall is not accessible, or whenever the active firewall is no crash, or active firewall is dead, the passive firewall will take over the active role, and the traffic will shift towards the new active firewall. Okay, so mainly the high availability is an concept where it can provide redundancy and avoid single point of failures. Okay, and we have in Palo Alto we'll be having two HA setups, two availability setups. One is an active passive, and other one is an active active. Okay, active passive is a normal, okay, normal setup where one firewall will be acting as an active and other firewall will be acting as an passive. Okay, and this active passive setup will be used when there is when there is no asymmetric path. Asymmetric path means the traffic is flowing from one way and entering your network into an other way. Okay, so in that case we'll be calling an asymmetric paths. And when there is no asymmetric paths, or when there is an traffic going from one device and coming inside a network, so those to from the same device we will be calling that as an symmetric path. Okay, so the other mode is active active. This active active setup will be used when there are asymmetric paths in your network. Okay, asymmetric paths, I told you, right? The traffic is flowing out from your network through one device and will be reaching to your network through return traffic will be reaching to your network from another device, which will be calling as an asymmetric path. In that case, active active setup will be used. Okay, and here we in this high availability we'll be having link types. Okay, we'll be having HA links. Okay, we'll be calling as an HA links. One is an HA1 link, which will be calling as an control link. Okay, control link, and other link is an HA2 link, HA2, which is an data link. Okay, control link and data link. What is the purpose of HA link and what is the purpose of data link? Okay, let's suppose whenever you are configuring high availability between two firewalls, you have to connect HA1 between two firewalls, and HA2 between HA2 link also. Okay, so for some firewalls we will be having dedicated HA interfaces. So if you have the firewall with dedicated HA interfaces, you connect those HA interfaces. Okay, you can see that the notation will be all if you see dedicated HA interfaces on the firewall, you have a notation. This port is for HA1 and this port is for HA2. Okay, so connect the HA1 of the one firewall to other firewall, and also HA2 of the one firewall to other firewall. Okay, if some firewalls we have some firewalls where there are no dedicated H interfaces. Okay, so like PA 200 series firewalls and PA 400 series firewalls, we don't have any dedicated H interfaces. Okay, in that case what we can do is we can configure data plane interface. Okay, we can configure data plane interfaces to participate in HA. We can configure that link type as an interface type as HA, and connect those interfaces, one for use one for HA1 and one for HA2. Okay, so the HA1 will be mostly used to exchange hello messages, sorry, hello and heartbeat messages. Okay, these hello and heartbeat messages mainly used for the keep alive. Okay, and apart from hello and heartbeat messages, it will also exchange HA information. Okay, this HA information will be having the election process. Okay, I will tell you the election process, how election process will be happen, and also the hello intervals. Okay, and apart from that, it will also exchange the management information of two firewalls. That is called, that's why we are calling it as an control link. And HA2 link will mainly used for sessions. Okay, exchange of sessions, exchange of session information, and also tables. Okay, tables like route tables, ARP tables, and if you have any IPsec, it will share the IPsec information. Okay, all this information will be exchanged in the data link layer. Okay, these are the two links where the first link, the first HA1 link mainly used for negotiating hello and heartbeat messages as well as HA information and also the management interface between the two firewalls. And data link is mainly used for after forming active passive, we need to exchange the sessions, right? Whatever the sessions that are forming on the active firewall, this active firewall will send that session information to the passive one. Okay, and apart from the session information, it will also send the route tables, ARP tables, and IPsec information to the passive. Okay, why we need to send all this information means whenever this active went down, it has to be take the active role immediately, right? It has to, it doesn't want any 1 second outage as well. Okay, 1 or 2 seconds outage also, we don't accept 1 or 2 seconds outage as well. Okay, so in that case what we can do is, if you have these all these session information, route tables, ARP tables, all these things, this will take over the traffic instantly. Okay, when this active down, this passive will take over the traffic instantly and pass the traffic from this passive firewall. Okay, which is our in that case, which is our new active. Okay, so that is the case. This HA2 link will mainly used to exchange the all this information. Okay, and apart from this HA link, HA1 and HA2, we have the HA backup links as well. HA backup links, in the same way how we are using redundancy for the firewalls, here also we are using redundancy for the links. Okay, HA backup link, HA1 backup, and HA2 backup. Okay, HA1 backup will mainly use to have redundancy for HA1, and when this HA1 goes down, all the information about this hello and heartbeat messages, such information will be shared using the HA1 backup. Okay, if HA1 backup goes down, there will be no hello and heartbeat messages, right? In that case, we are not able to send any information between active and passive, so there will be failover will be happen. Okay, so in order to avoid that, we can configure HA1 backup and also the HA2 backup. Okay, to exchange this information. Here one thing you have to remember is this HA1 backup, sorry, HA1 link is an bidirectional. Okay, this HA1 link is an bidirectional. Why it is bidirectional means, whatever the things that you are exchanging, okay, we need to negotiate on both the sides. Okay, this has to be sent all this information, and this passive also send all the information in order to negotiate. Okay, and also if you send H information, both will be select the which device want to participate in the active and which device will take over the passive role. Okay, so in that case, the HA1 information will has to be flow in the both ways in sense from active to passive, and as well as passive to active. But The HA2 data link is an unidirectional only. Okay, always the information has to be flown from unidirectional. Always the information will flow from active only. Okay, because all the traffic will be flown from the active only, right? There will be no traffic on the passive. In that case, the passive will don't have any sessions. Okay, real traffic sessions. Only the active will be maintaining the sessions. Okay, so those active sessions will be shared on the HA2 from active to passive only. That is why this is an unidirectional, and the HA1 link is an bidirectional. Okay, just remember this. The HA1 is an bidirectional and HA2 is an unidirectional. Okay, and apart from HA links, we will be having election process. Okay, how active passive will be elected in the high availability. Okay, election process. Here in the HA1, it will be sharing HA information, right, using a HA1 link. So in the HA1, we will be having priority. We will be having device priority, which will be helping for the firewalls to elect the active and passive. Okay, by default, the device priority will be 100, but here how the election process will take, right? The device or the firewall which has low priority value. Okay, low value or low priority value, that will be elected as active. Okay, so by default we will be having device priority 100, right? If you want the firewall, let's suppose this is our firewall 1 and this is our firewall 2. If you want firewall 1 will be if you want firewall will act as an active, just change the priority. Okay, just change the priority here or here. Okay, this firewall should be the priority low when compared to this. Okay, whether you can change here or whether you can change here. Okay, if you are changing here, just change the priority to, by default it will be 50, and you can change, sorry, by default the device priority will be 100. You can change here as an 50, and you can keep this default priority 100. Okay, so in this case, this firewall, this device priority having 50, and this device having priority 100, so it will be electing as an active. Okay, if you want change here, you can go with device priority. Okay, on the device one we will be having 100, on the other device you can configure priority as an 200. Okay, in that case this value will be 100, this value will be 200, this will be electing as an active. Okay, you can change priority on any of the device. Okay, when you see the default priority 100, and you can change any device priority based upon your requirement. Okay, if you want this firewall as an active, you can change accordingly. Okay, that is, there is no such thing you have to change here only and you have to change here only. No, no such thing. Okay, if you want any device become as an active, you can change there itself. Okay, and the firewall which has low priority, that will be acting as an active, and the firewall which has high priority value, okay, that will be electing as an, will be elected as passive. Okay, so this is how election process will be take place. But here one thing you have to note down is, if priority matches. Okay, if priority matches, how it will elect the active and passive. Okay, if priority matches, the firewall which has low MAC address. Okay, the firewall which has low MAC address, that will be elected as active. Okay, that will be elected as active, and other firewall will be passive. For suppose I mentioned, right, the default priority is 100, you forgot to change the device priority. Okay, in that case both the firewall will be having 100, right? So if the priority matches, the firewall with low MAC address will be electing as an active, and other firewall will be electing as an passive. Okay, this is how election process will take place. Okay, yeah, sure, I will say that. Okay, and next thing you have to know about this is an HA states. HA states will be having multiple HA states. The first one is an init state, second one is an active state, third one is an passive. Okay, and next is an active primary, which is you can see in the active setup, and active secondary, and other thing is an non-functional, tentative, and suspend. Okay, these are the firewall state that you can see. If you are forming an setup between of two firewalls using an active passive, you will see init state, active passive state, non-functional, tentative, and suspended. You cannot say active primary and active secondary. This active primary and active secondary will mainly for the active setup. Okay, whenever you configured HA on the firewalls, that will be first it will be going to the init state, and it will tries to negotiate the parameters with the other firewall. Okay, whenever synchronization starts or whenever you configured HA on the firewalls, it will be moving to the init state. And once the all the parameters are parameters in the sense all the hello intervals and HA information are exchanged between the both the sides, they will be checking the device priority, and the device which has high priority, that will be electing as an passive, and the device which has a low device priority, that will be electing as an passive. Okay, in that case you can see the device which has high low priority value, that will be electing as an active, and you can see the state as an active, and the device which has high priority value, you can see the state as an passive. Okay, and in the same way, the device which in the active setup, the device which has high priority value, you will be that will be seeing as an active secondary, and here the active primary will see where the device priority value is low. Okay, and these are the normal things. Okay, and these are the some states that you can see whenever something is happen on the firewalls. Okay, the non-functional state, tentative state, and suspended state. So here the suspended state, you can see when there is something is happen on the firewall, or someone user requested. Okay, so what you have to do is, if you want to see if you want to upgrade any of the firewalls in a HA state, okay, what we can do is we can keep active firewall in a suspended state. Okay, the suspended state may be due to user requested, or maybe there may be something is happen on the firewall, something in the happen in the firewall means, if there are any see here, if you want to form HA between your firewalls, the thing that you need to mention that I want to mention is both the firewalls in the both firewalls in same model. Okay, the both firewalls are of same model. I have to tell you this in the while we are configuring, okay, in the lab, but I am telling you before. So if you are forming high availability between two firewalls, the firewall should be of same model. Okay, if you are using 220 here, the other firewall is also of 220, and if you are using 800 series like 830 or 820, you have to use the same 820 or 830 firewall here. If you are using 440 or 440, this will be side as a 440 only. Okay, so the both the firewall should be of same model, and also both the firewall should be in the same PAN-OS version. Okay, should be in same PAN-OS version. So if you want to form high availability, both the firewalls, okay, if you the both the firewalls should be in the same PAN-OS version. If there is any mismatch in the PAN-OS version, so the high availability will not be formed. And also the configuration, okay, both the firewall should have same type of configuration. should have same type of interface configuration. Okay, I'm mentioning here interface configuration means whatever the interface that you are connected on the active firewalls, the same interfaces should have be connected, because whenever you are failoring, okay, whenever the passive rule take over the active, whatever the interface that the traffic is flowing, the same interfaces should be on the passive also. Okay, so let's suppose if you have an three interfaces connected here, the same type of three interfaces should be also connected here. And what are the speeds that you are using on these interface, let's suppose each interface of 1 GB, we can also use each interface of 1 GB only. Okay, so in that case you have to use the same type of interface configuration. If any of the these if any of these conditions are mismatched, the firewall will be in the suspended state. And in the suspended state you can see that the reason, okay, the reason of suspended, whether if it is an user requested, that will show user requested, or if it is a suspended by the firewall mismatch, okay, any of these conditions mismatch, it will show there. Okay, in that case you can see that. And the tentative state, when it will go into the tentative state means if any of the firewall resources are high. Okay, high in the sense we have a management plane CPU and also data plane CPU. So whenever there is a resources utilization is high, there is management CPU and data plane CPU will the firewall receiving high, this firewall will be won't able to process the next traffic. Okay, will won't be able to process the other traffic. So in that case what it will do means the firewall will go into the tentative state. Okay, and in that case you need to check what is the how the firewall resources, and what causing the issue. Okay, if it is a management plane CPU or data plane CPU. And the non-functional state, we can see the non-functional state when there is any of the configuration. Okay, any of the configuration is mismatching, or any of the configuration is not synchronizing between active and passive firewalls. In that case the non-functional, when you can see the non-functional state on the firewalls, as well as if there is any HA link went down, or if any firewall is the firewall is behaving abruptly, in that case is also you can see the non-functional state. Okay, so these are the states that you can see whenever you have configured high availability. Okay, these three states you can see whenever there is something issue happen on the firewalls. If you are seeing these state, the firewall is fine and working. Okay, someone is asking anything. All right. Okay. Okay, these are the HA states. And the next thing is we'll be having some failover conditions. Okay, I will talk to that later. And now we need to know the concept of preemption. Okay, preemption, we have a concept of preemption here. Okay, this is also helpful whenever you are when the firewall went down and it came back. Okay, let's suppose take a scenario. We have a scenario like we have a two firewalls, and all the negotiation is happened, and the fire we have all the negotiations happen, and the firewall formed the firewalls are in active passive. Okay, take this firewall is an active, this firewall became active, and this firewall became passive. Okay, and this is an HA1. Okay, the top one, let's consider it as an HA1, and bottom is an HA2. Let's take this scenario. Okay, and every traffic will be flowing through this active firewall and going out, and for some reason my active firewall is not accessing, and my active firewall got crashed. Okay, my active firewall got crashed, and all the traffic will be now shifted. Okay, how it will be shifted means we have HA timers. Okay, HA timers, like I will tell you the HA timers afterwards after the preemption. And but whenever the active firewall goes down, whenever the active firewall goes down, the passive firewall will wait for 3 seconds. Okay, the passive firewall will wait for 3 seconds to see the key palos. Okay, key palos means it will be we are exchanging an hello and heartbeat messages, right? If the passive firewall is not seeing hello and heartbeat messages for 3 consecutive seconds from the active firewall, this passive firewall will consider the active is dead, and it will be taking the active role. Okay, it will be taking the active role. Now the passive is a new active, right? It will be taking active role, and all our traffic will be flown from this passive new active one. Okay, and after some time we have brought back the active firewall. We have brought back the active firewall, and it will be added to the HA. Now will it take the active role back again, or it will be acting as an passive? Should anyone answer this question if you have any idea on this? See here, before our active firewall went down and my passive firewall acting as an active. Okay, now we brought back the active firewall. We brought back the firewall which is active before, and it is participating in HA. Will it be taking active role, its active role back, or will be acting as an passive here? You understand the concept, right? Here my before the firewall which is active before, it went down. Okay, it went down in sense maybe some crash happened, or maybe the firewall itself went in an shutdown mode. In that case the passive will take over the active, right? So now we troubleshooted the firewall, and we brought back the firewall again, and we have added to the HA. And will it take its active role back, or will it be participating in an passive? Okay, this is partially correct. See here, whenever our firewall went down, okay, whenever our active firewall went down, and it will be back again, and connected to the HA. So if we have enabled the preemption, we have a concept of preemption. If we have enabled the preemption on both the firewalls, our active firewall will be our active firewall went down, right? Now the firewall is back. Okay, whenever preemption is enabled on this will take its active role back. Okay, it will take its active role and will be acting as an active. Okay, it will be acting as an active once it is back from the shutdown or from the crash state. And again it will be always, it will be moving from active to the passive again. Okay, it will be moving to the active and passive, active to passive again. Okay, whenever there is preemption is enabled, you have to enable preemption on both the firewalls, here and here. And so whenever the active goes down and we brought back the device again into the HA, it will take over its active role. Okay, when preemption is not enabled, it won't take its role back. Okay, it won't take its role back. It will be added to the HA as a passive. Okay, it will be added HA to it will be the our active, which is the firewall which is active before, it will be added to the passive. And whatever the firewall that is acting as a new active, that will be in the active state only. Okay, when preemption is disabled, if the preemption is enabled, it will take its active role back. Okay, this is the concept of preemption. Do you have any confusion here? Preemption, whenever you are configuring election settings, you can see the preemption option. So you can enable that preemption on both the firewalls, so that it will act accordingly. Okay, any clarification or any questions on this preemption? Yeah, whenever the active goes down, the passive will wait for 3 seconds to get the key pillars from the active. Sorry. Oh yeah, yes, that's correct, that's correct. Because our active firewall is down, right? So the passive will wait for 3 seconds and it will take the active role. Okay, in that 3 seconds, some if the users are trying to access anything, they will lose the access. In this preemption instance, not only the preemption, okay, if the preemption is not enabled as well, the firewall, this passive firewall will wait for 3 seconds. This what I'm saying is, if the preemption is enabled and we have brought back the active, okay, the firewall which is active before, it will be taking its active role again back when the preemption is enabled. This is not related to this whatever we are discussing, okay. Preemption concept is whenever the active went down and it is back again and participating in HA, it will take its active role again when preemption is enabled. If the preemption is not enabled, it will be added to the HA as a passive. That's the concept here. Yeah, 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 guys. And we have next is an HA timers. Okay, we have HA timers where hello interval. Okay, we have hello messages. Right? This hello interval is, sorry, it is an 8000 milliseconds. Okay, 8000 milliseconds, and the key pillars is, so, and heartbeat. Okay, heartbeat is mainly for 1000 milliseconds. Means hello intervals will exchange for every 8000 milliseconds, means it is 8 seconds, and the heartbeat messages will be exchanged in every 1000 milliseconds, means that is in 1 second. Mostly the heartbeats will be in the form of pings. Okay, how we can use the ping? Okay, it will be in the form of pings. It will use an ICMP messages for every 1 second. Both the active and passive will share the uh, pings. Okay, and apart from this, we'll be having preemption also. Okay, preemption timer and promotion timers as well. Okay, preemption timers means the time that the firewall will be the firewall will bring back its active role. Okay, we cannot decide at what time. Okay, but we'll have a preemption timer, the time at which the firewall will gain its active role back. Okay, once this become active, sorry, once this become brought back to a running state, and it will take its active role, right? So that time will be calling as a preemption time. And promotion time means whenever this active went down, whenever this active went down, this passive firewall will become active, right? That is a promotion time. Okay, maybe you can call it as in 3 seconds, and the promotion time will be like 3000 milliseconds. Okay, 3000 milliseconds. So the the time taken by the passive firewall to be acting as an active when the active firewall went down. Okay, that is a promotion time. That will be at 3 seconds. Okay, because the passive will wait for 3 seconds for the key allows, and after it is, if it is not receiving, it will take over the active role. Okay, that is the promotion. Okay, the passive will becoming an active, that is a promotion. So the time taken by that means that is an promotion time, that will be an 3000 milliseconds. But the preemption time we cannot say. Okay, because this preemption time we don't know when we will get a firewall back, or when we'll be acting as an when will add to the HA. Okay, these are the some HA timers that we can see. Okay, And we have a next topic is an failover scenarios. Okay, we have failover scenarios. These failover scenarios mainly useful when you are troubleshooting the HA. Okay, let's suppose the first failover scenario is when HA1 went down. Okay, HA1 went down. This is the first scenario. Let's suppose take our firewalls which are in HA. One is an acting as an active, one is an acting as a passive, right? So we have the HA links, right? HA1 and HA2. Okay, but we haven't configured any backup links here. We have just configured HA1 and HA2. We don't have any backup links. Okay, this is a HA1, this is an HA2, and this firewall acting as an active, and this firewall is an passive. Okay, so our first scenario is HA went down, HA1 went down. Okay, this is our HA1, right, where we are negotiating hello messages, heartbeat messages, HA information, all the things will be exchanged or negotiated using HA1. Okay, let's suppose this HA1 only went down. Okay, maybe there is an issue here, or maybe there is an issue on this firewall. For some reason this HA1 went down. Okay, so in that case what it will do, the exchanging of the hello and heartbeat messages will be lost, right? So what passive firewall will do? The same, the passive firewall will be waiting for 3 seconds. Okay, it wait for 3 seconds, and it will be taking over, because the passive firewall is not receiving any key payloads from the active, but active is fine here. The active firewall is up and running, and but there is no HA1 link between active and passive went down. So the passive firewall is not receiving key payloads from the active. So it will wait for 3 seconds, and in that 3 seconds, if the passive firewall is not receiving, it will be taking over active, right? So in this case, the passive firewall will become active. Okay, and also our active firewall is up and running, it is taking the role of active. Okay, in this case both the firewall will be acting as an active, and the traffic don't know which firewall it has to be passed. Okay, we don't know which firewall is passing the traffic. Okay, so this scenario will be called as a split brain scenario. Okay, we'll be calling as a split brain scenario. Okay, when split brain scenario occur means, what is split brain? You may encounter an question in the interviews. Okay, whenever they are asking about high availability, maybe there is a chance to ask what is split brain scenario in high availability. Okay, when split brain scenario will occur. Okay, split brain scenario occur when both the firewall is acting as an active. Okay, why the firewall will be acting as an active? Maybe there may be any HA link went down. Okay, HA1 link went down, and in that case we don't have an HA1 backup in order to exchange the HA1 information using HA1 backup. So in that case both the firewall will be acting as an active, right? So this passive firewall will become active, and our active firewall is up and running. Okay, in this case both the firewall will be acting as an active. That scenario is called split brain scenario. Okay, how we can avoid split brain scenario? How can we avoid this situation? Okay, how can we avoid this situation means, we can avoid this situation by configuring HA1 backup, because we don't have HA1 backup, right? By configuring HA1 backup. So we can avoid this by configuring HA1 backup. So the HA1 backup will take over the HA1 role, and it will be negotiating all the HA1 information through the HA1 backup link. Okay, mostly you can configure H1 backup on the management interface, okay, because the management interface beyond the two firewalls will be up and running always, okay. There will be a slight chance that management interface goes down. So the recommended, or the what we call the Palo Alto will recommend to configure H1 backup on the management interface, okay. You can also configure using any data plane interface, but the best practice to configure H1 backup is on management interface. So whenever our H1 link went down, our firewalls management interface will always be up and running, right? So these two firewalls will use a management interface to exchange the key palos, okay, to exchange hello and heartbeat messages. So if you don't want to configure management interface, you can use one more interface between active and passive. You can configure that as an H1 backup, okay. So you can avoid in that case. And this one more scenario will be also available here, okay. For suppose if you have any intermediate device, okay, basically you are connecting both the firewalls directly, okay, but using an your RJ45 cables. You can use RJ45 cables and connect both the firewalls directly only, okay. For suppose if you have any intermediate device in between, okay, intermediate device in between your active and passive firewalls, okay, all your active all your HA information will be flowing through this fire or any intermediate device. Let's suppose you have a router or switch in between, okay. Let's suppose you have a switch here, okay, have a switch here, and all the information from active to passive and all the things that are negotiating via switch, okay. For suppose if the switch went down, okay, here in this case our firewalls and links are all working fine, okay. We have an HA1, we have an HA2, here also HA1, here also HA2, okay. All the links and all the firewalls is working fine, there is no issues, but there is an issue with the intermediate device which is called a switch, okay. This switch went down, and there is an intercept of the traffic, okay. Intercept in the sense no information will be flowing out of here, okay, from this or from this, no information is flowing, okay. In that case also you can this split band scenario will occur, because if the intermediate device went down, there will be no exchange of information, right, and this passive firewall will become active after waiting for 3 seconds, and it will be taking as an active role, and here the both the firewall will be acting as an active, okay. In that case also the split band scenario will occur. To avoid that, we need to bring up this switch in between, okay, or you can remove this switch and you can directly connect the active passive directly, okay, using your HA links, okay. So this is also one scenario you can see. I think someone has unmuted. Yeah, hi Satish, do you have any questions here? No, sorry. Yeah, okay. Oh, okay, okay, fine. And this is also one scenario you can face whenever you are whenever you have a firewalls in the HA, okay. And second scenario is link monitoring. We can call it as an link monitoring, okay. Here in this case, what you can do is whatever the interfaces that are connected on your firewalls, you can monitor those links, okay. Let's suppose this is one scenario where you have a firewalls in HA, okay. You have an interfaces, right, other than HA you will be having other interfaces as well, right, okay. If you want to monitor these interfaces also, you can monitor, okay. In that case also the firewall failure will happen, okay. Let's suppose this is an active and this is an passive, and we have an HA1, HA2, okay. So this is a case, and here what you are doing is in order to monitor the links that connected to the firewalls, you can configure link monitoring profile, okay. We'll be having link monitoring profile, link monitoring profile, and once you configure link monitoring profile, you have to add the interfaces. Okay, add the interfaces here. What are the interfaces that you want to monitor while on the HA? Okay, while configuring HA. Okay, so let's suppose I have three interfaces. I have Ethernet 1/1, Ethernet 1/2, and Ethernet 1/3. Okay, so I want to monitor all these three interfaces that are connected to my firewalls. Okay, so here there is a failure condition as well. Failure condition will be having two failure conditions, which is any or all. Okay, any or all means if you configure failure condition is any, okay, you have included three interfaces, right? If any one of the interface that goes on within these three interfaces, the firewall failover occurs. Okay, if any interface you have configured link monitoring and you have included interfaces and you have a failure condition is any, if any interface in these three interfaces went down, okay, let's suppose you have Ethernet 1/1 which went down, okay, and failure condition is any, the failover will happen. Okay, this will become as an passive and this will become as an active. Okay, actually whatever the firewall will be acting as an active, that should be in the same state. Okay, this failover should not happen. Okay, if failover is happen, something is happened in your network. Okay, you have to identify whether it is an HA link went down or any of the intermediate device went down or any link monitoring, if you have configured link monitoring, any of the interface that went down. Okay, or and if the failure condition configured is an all, okay, until unless all the interfaces goes down, the failure will not happen. Okay, if you configure failure condition is all and if Ethernet 1/1 went down, it won't failure. Okay, it won't exchange the roles. Okay, until unless all the interfaces goes down. Okay, 1 2 3 all the goes down, the failure should not happen. Okay, so better you can go with the failure condition is all, because maybe one or two interfaces abruptly or unintentional, like maybe there may be some chance where one or two interfaces will go down on the firewalls and it will be back again. But if it is shut down, or if it is the interface is down, if for 2 to 3 seconds also this failure will happen. Okay, if the failure will happen, you need to identify the issue. Okay, so the failure conditions are here, right? These are the failure scenarios. If the failure happen, you need to check first thing is an HA, and next thing is if there are any intermediate device, or if that is fine, you need to check link monitoring, and you need to check the interfaces, what are the interfaces that are included, and also the failure condition. Okay, these are the two things. And the next thing is also the path monitoring, which is a third one, path monitoring. Okay, in this case also you will be having you if you want to monitor, okay, from the firewalls to reach the destination. Okay, to reach my destination 8.8.8.8, let's take a scenario. Okay, this is my scenario where I will be reaching the 8.8 through, I have two routes. Okay, 10.10.10.1 and also and 20.20.20.1. Okay, I have these two scenarios. Okay, I have this case where I can reach 8.8 with two paths. Okay, one is from 10.10.1 and another one is an 20.1. Okay, we are monitoring this path. Okay, and we'll be also having failure condition here as well, failure condition, and here also we'll be having any or all. If you configure any of the path goes down, okay, any of the monitoring path goes down, the failover will happen. And if you configure condition as an all, until unless all paths went down, the failover will won't happen. Okay, so these are the three main conditions you need to check while troubleshooting. These are the three main conditions. Okay, if the failure is happened, check HA if HA1 went down or not. If HA1 is not down, check if there are any intermediates between our active and passive firewall. If there are any intermediate devices between our active passive, check whether the uptime of those devices. Okay, if the uptime is okay and if it is if it is not rebooted or if it is not shut down, you can go with the second thing, okay, link monitoring, and check if the link monitoring is configured or not. If link monitoring is not configured, skip this step and check this path monitoring. Okay, if path monitoring is configured, you can check this, or otherwise you can also skip this. And here the link monitoring is configured. Check what are the interfaces that are included here. See here on the firewalls, you can see by default link monitoring and path monitoring is enabled. But here how it will means, until unless you added the interfaces in the link monitoring, and until unless you added the path in the path monitoring, this will not work. Okay, because by default it will be enabled, and if you add, then only it will work. Okay, and you can also check the failure condition, and you can check if based upon the failure conditions if any interfaces went down in the logs. Okay, system logs, you can see if interfaces goes down, the firewall will log that in the system logs. And we'll be also having one demand called BRD agent. Okay, this is the demand where the board information, okay, the firewall information, the data plane, okay, we'll be calling as an data plane interface information will be logged. Okay, whenever up or whenever down, this will be logging the sessions. Okay, you can check brd agent.log so that you can comes to know. And apart from brd agent, you can also check in the system logs. Okay, that will be also one case you can check. Okay, and these are the three failure scenarios. And apart from this, we'll be having a last topic called passive link states. Okay, passive link state, these are mainly on the passive firewall. Okay, let's suppose we'll be having active passive. Okay, active passive, and here we have connected a ha1, ha2 will be having links, right? Ethernet 1, Ethernet 2, Ethernet 3. All the interfaces that are in active firewall will always be in the forwarding state. Forwarding state in the sense, these are the up and running, and it will be carrying a traffic. But the interfaces that are in the passive, that will be in the shutdown state, or we'll be having two passive states. Okay, the all the links in the passive, all the interfaces that are connected to the passive will be in shutdown state, or auto state. Okay, what is shutdown and what is auto on the passive firewall? Okay, the shutdown state means the links are in the shutdown state, and if it isn't shutdown, that won't participate in the traffic, right? Obviously, whatever the links that are connected on the passive, that won't take participate in the traffic. Okay, because the firewall is standby, acting as a standby, and it won't participate in the traffic. So the interfaces will also not the interface that are connected to the passive also will not take participate in the real time traffic. Okay, we have a two link states, one is in shutdown and passive. If you configure shutdown, the interfaces are in shutdown state, and if you configure auto, the interfaces are in up. Okay, the interfaces will show as an up, even though the interfaces are up. Okay, it won't participate in the traffic. Okay, it won't participate in the traffic. Okay, you can get an you will get an one thing here. Okay, even though the interfaces on the passive is up, why don't it participate? Okay, because the firewall is not carrying any traffic, right? All the traffic, all the active traffic, all the real traffic will be carried by the active firewall. Even though the interfaces are up on the active firewall, when we configured active link states in auto state, it won't participate. Okay, so why we have these two states in the passive means, see here, whenever failure happens, okay, whenever failure happens, if the interfaces are in shutdown state, it will take some time to bring the interfaces up, and it will place the traffic in those interfaces, right? So if the interfaces are in auto mode, okay, the interfaces are in up state, So if the interfaces are up state, it will be instantly take the traffic, okay, whenever failover happen, okay. So the recommended here is that you can go with an auto, okay, instead of shutdown, because if you put the interfaces, passive interfaces in the shutdown mode, it will take some time to bring the interfaces up and participate in the traffic, right? So in order to avoid this little convergence between interfaces down and up, so you can better go with an auto state. If the auto state, the interfaces on the passive will be in up state. Whenever failure happens, already the interfaces are up and it will instantly take the traffic without any delay, okay. So that is the main reason we'll be having two states, okay. So the recommended one is an auto, okay. You can configure the passive link states on auto, okay. And these are the things that we are studying in high availability of Palo Alto, okay. Do you have any questions or do you have any clarifications? Let's see if I have covered everything. HA modes, backup links, okay. Yeah, see here I forgot about this HA3, okay. HA3 will mostly helpful in the active active setup, okay. In the active passive we will not see the HA3, we will see we only HA1 and HA2, but HA3 will mostly seen in the active active for packet forwarding, okay. But active active passive active active setup will mostly we cannot get that situation, okay. Only rarely 100 out of 1 out of 100 topologies you will see the active active setup. So mostly you will encounter only the active passive setups, okay. That's why we are not mostly focusing on active active and HA3 link, okay. So mostly HA3 link will be, if you know the active active deployment, this HA3 link will mostly use for packet forwarding, okay. And apart from that, yeah, link monitoring, path monitoring, HA timers, firewall states, yeah, everything is covered. Failover scenario, split branch scenario, passive link state, yeah. Yeah guys, we have covered everything. You can just let me know if you have any further questions, if you have any clarifications. This is one of the important topic and also interesting topic as well, okay. How the firewall will be acting, how the firewall will behave in the redundancy, and how these firewalls will be election process, okay. Same like how the DR BDR will be elected in the OSPF, in the same way this also will be election, but election process will be different, but in the same way the election will be held in this to in order to elect active passive, the election will be happen, okay. Any questions or any queries? If you take any network, they will be forming high availability, okay. Without high availability no one will be going forward, okay, because they are investing millions of rupees, okay, in order to provide the services, right. If any single point of failure they cannot bear that, okay, they will be losing millions of rupees, okay. To avoid that they will be going with the redundancy. So every network, if you take any network, the redundancy will always be there. And if you see the Palo Alto firewalls, this high availability will be used, okay. And these are the things that you can see whenever you are configuring high availability, okay. Any questions or any clarification that you need on this? Anyone? No, that's not possible, because it has to be negotiate the same parameters, right? So maybe the other vendor firewall will be having different and this firewall will be having different, and the election process on the other firewall will be different, and this vendor will be different, right? That is not possible to form HA between two different vendors. You if you have to form between the same device, okay. That's what we have the first thing that we need to consider is the firewall is of same model. Okay, that is the first thing that whenever you are configuring HA, this is the first thing that you need to note down. Okay, even in the Palo Alto firewall also you should have used the same model. If you are forming high availability between PA 220 and PA 400, that won't happen. Okay, even if you see in the Palo Alto itself, it won't happen. Then why, how it should form HA between two different vendors? Okay, that's not possible. Okay, any other questions? Yeah, okay guys, I will take it as no. Okay, and if you don't have any questions, we can wind up this session here, and we will continue the HA lab on Monday at the same time. Okay, I will show how can we configure and how election process will take on Mondays in the lab configuration. Okay, thanks guys, thanks for joining. Have a good weekend. Bye.